All right, so yesterday we talked about rational numbers and real numbers. We said in Algebra 1 we're only going to deal with real numbers. What's the difference between a rational number and an irrational number? Rational has a pattern. So if it has a decimal, that decimal has a predictable pattern, right? So something like, can someone give me an example of a rational number that's a decimal? What will be an example of a rational number that's a decimal? Reggie? 6.33333 repeating, right? So that's a rational number. So even though it goes on forever, it's still rational because you can predict what will happen, right? Remember, rational means that it makes sense. Irrational means it doesn't make sense, it's not predictable. So what would be an example of an irrational number? Blah, 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 right? Okay, so yeah, perfect. So something that doesn't have a pattern that goes on forever. What's our most common irrational number? Pi. Yeah, we use pi all the time. That's the most common irrational number. Also, something like the square root of what would be irrational? 13 would be irrational. Good. What else would be irrational? The square root of a lot of other stuff like 11. What about square root of 16? That's 4. So is that rational or irrational? Rational. And it's also a whole number and a real number and a integer. Good. Very good. Very good. Okay. How do you go about putting these in order? How do you go about putting those in order? You start with your negatives, right? Because if you're going from least to greatest, you start with your negatives. And negatives work kind of the opposite way of positives. So what's your smallest number up here? Negative 7.4. Very good. Negative 7.4 is your smallest. What's the next one? Does anyone know off the top of their head what decimal that is? 0.5? 4.5. Good. So negative 4.5. Okay, what would come next? 0.2 or 0.2. And then the biggest? 7.4. Very good. So that would be in order from least to greatest. If you did it the other way around, greatest to least, that's fine too because it doesn't say. If it helps you to use your number line, please do. But if it doesn't help you and it's a waste of your time, don't do it. All right, so today we're going to talk about how to translate between words and algebraic expressions, and then also how to evaluate algebraic expressions. So before we start that, what is algebra? What is algebra? Reggie, what did you say? Numbers. It has to do with numbers, right? Yeah, it does have to do with numbers, but you weren't doing algebra in kindergarten and you were using numbers in kindergarten. Numbers and letters? Okay. Numbers and letters. What are those letters? We call them variables. All right. So we use variables. We use letters to do what? They stand in the place of numbers that we know or that we don't know. Good. Numbers that we don't know. Exactly. So algebra is studying numbers that we don't know, and we use letters to stand for those. So then if you were going to define variable for me, if you were going to put a definition on it, what would you say? If you had to define variable, what would you say? Letters that, good, letters that take the place of numbers. Remember, if I write it up here, you should probably write it on your slides. Does anybody need the slides? Does anybody miss them? Okay. Letters that take the place of numbers. Do we use capital letters or lowercase usually? Usually lowercase. Good. What's the most common one that you think we use? X or ABC. Yep. You usually see X when you first start doing it, and then we start doing ABC. Does it matter? Could you pick other ones? You could use any letter you want. Why do we not usually use L? Looks kind of like a 1. All right, so we don't usually use L, but I don't care if you like the letter L, by all means use it, okay? When did you first start doing algebra? What grade? 8th? 5th? How many of you guys did problems like this when you were really young? Yeah? What are you doing there? You're finding the missing number, right? So is that algebra? Yes? Even though there's no letter there? You're still doing algebra. Does anyone have a guess on when you start doing problems like that? really early on, right? So like first or second grade. So you guys have been doing algebra for probably almost 8 years. All right, so you've been doing algebra for a long time. We just stick a variable in there. Okay, so you might not have been seeing algebra with letters from a very early age, but you were definitely seeing algebra. Okay, so basically we're filling in some blanks. What's a constant? What's a constant? Something that stays the same. Okay, it's going to stay the same. It's the numbers. It's the numbers in an algebraic expression or equation because they don't change value. So in this case, which is our variable and which is our constant? X is the variable. 7 is a constant. What about 4? Also a constant. All right, 4 is always going to be worth 4. When you count, it always is the same thing. Okay. Then we're going to talk about numerical expressions and algebraic expressions. But before we do that, what's an expression? The problem, except it does not have a what. If it's an expression, there's no what? Equal sign. Very good. So x plus 4 is an expression. X plus 4 equals 7 is a what? X plus 4 equals 7 is an equation. Very good. So an expression has no equal sign, and an equation is when you put an equal sign into it. So no equal sign. All right, so we're just going to talk about expressions. What do you think a numerical expression is? An expression with numbers. All right, so those are all examples of numerical expressions. So 1 plus 8, 3 times 2, 9 divided by 3. Those are all expressions. What about an algebraic expression? Isabel? X plus something, so x plus 5, x minus 12, 3x, 8 over x. All of those are algebraic expressions. So expressions with variables. And that's the only difference. So a numerical one just has numbers, an algebraic one has numbers and variables. Can you solve an expression? Can you solve it? Like right here, x plus 5. Can you tell me what x equals? No, why not? You need an answer. So you need an equation before you can solve it, right? You can simplify it. Right up here, can I simplify 1 plus 8? Yeah, what is it? 9. Good, you simplified it. What's 3 times 2? Simplified, good. 9 divided by 3? 3, simplified, good. Can you solve x minus 12? No, because I don't know what it's equal to. So x could be 40, x could be 80, x could be a whole bunch of things. You can only solve it if it's an equation and it has an equal sign. All right, in this case, does anyone know what x is? X can't be any number here. Why is it 3? Why is it 3? Because it has to add up to 7, so 4 plus 3 is the only thing that will give you 7, right? So x must be 3. So if it's an equation, you can solve it. If it's an expression, you can only simplify. All right. When we're looking at algebraic expressions and when we're looking at translating them between words and expressions, we want to look at words that are called keywords. So what are some keywords that indicate that you're going to be adding? What are some keywords that might indicate that you're going to be adding? Daniel? Some. What's another keyword that tells you I'm going to be adding? Shout out. Just be loud. I just can't hear you. Together. More than. Together. More than. So you might say like 7 more than x, which would be like x plus 7. Good. All right. Any others? What? Plus, yeah. Plus. Added to. Addition. Total. All right, there might be some others, but those are kind of the basic ones. What about subtraction? Difference, take away. Someone said something else. Difference, take away. Minus. Subtract. Less than. I heard someone say compare. How would that look? Like, all right, the only thing I want to say about less than, so if I say 5 less than x, what does that look like as an expression? 5 less than x. So that would be less than 5. So what's 5 less than x? X minus 5. What does it do? It switches the order. So less than is kind of a tricky one. So just be careful with that. And because it's tricky and teachers are tricky, I will use it all the time. So less than flips the order. It does a weird thing. So 5 less than x actually would be x minus 5. So just keep that in mind. We'll do some examples with that. Whereas 5 minus x is just 5 minus x. All right, what are some words with times? This is supposed to be a division sign, by the way. Product, good. Multiply. Times. There's a couple more that we see a lot, but you might not be used to them yet. Anytime you see the word of usually means multiply, okay? So when you see like percent of, like 75% of 20, you would do 75% times 20. So of means times, and also each. Okay, so if I say I have 5 bags, each one has 10 apples, you would do 5 times 10 to figure out how many apples. Sometimes each is division. Very good. How can you tell when it's division and when it's multiplication? Would you say, like if I said I have 5 bags, each one holds 10 apples, then you'd multiply. How could you change that problem so that it was division? Very good. So if you have the total number of apples, good, then you would figure out you'd use division. What other words indicate division? Quotient. Divide. Anytime it asks you to split things into groups, okay? So split or groups. Are these all the words you'll ever see? No, but those are the ones you'll most commonly see. Okay, so that's why we call those the key terms. So a lot of this, when we're translating, we're taking things basically from number language into word language or vice versa or backwards. And a lot of times you can do things the easiest way possible. So if I say to you, like, translate this into words, if you want to just use the word plus, by all means just use it. Okay? You don't have to use the most complicated word in here. I don't see a lot of people writing quotient. I wish I did. It's a good word. All right, but I don't see it a lot of times. Most people will be like x divided by 2, and that's fine. Don't make it overcomplicated. Okay, so how are we going to use that? Well, we're going to take that, and I'm going to give you something like this, number 1, and I'll say translate this into words. So what are some ways that you could say number 1 there? X plus 3. What else could you say? X added to 3. The sum of x and 3. Are any of those wrong? No, those are all right. Does it matter which one you use? No. By all means, if you want to just say x plus 3, say x plus 3. Make it easy on yourself. We're going to do plenty of things that are hard and you cannot make easy, so make the easy stuff as easy as you want, okay? All right, what about number 2? 2 times y. The product of 2 and y, good. 2 of y, good. Could you say y times 2?
No. Yes. It depends if you might switch up.
Okay, so technically this is not y times 2, this is 2 times y, but does the order matter in multiplication? No. So if you said that, I'm not going to mark you wrong. Would that work for a division problem? No. Does the order matter in division? In division and subtraction, okay? Multiplication and addition are, I'm going to be so happy if anyone knows this. It's a C word. Does anyone know the C word for what it means when you can flip them back and forth? No. Close though. What's it called when you drive to work? That's your, like every day, your parents get in their car and they commute to work. I don't know. Commutative. The commutative property means you can flip back and forth. Okay? So the commutative property means you can flip them back and forth. All right? So the commutative property does not work for 3 and 4. You cannot switch the order. Why is that? How come you can't switch the order with subtraction? Yeah, it might be negative, right? What's 5 minus 3? 2. What's 3 minus 5? Negative 2. Okay? So it makes a difference. How could you say number 4? How could you say number 4? What are some ways you could translate number 4? The quotient of k and 5. Good. What's one more way you could say it? Yeah, k divided by 5. Good. Okay. You're also going to have to do it backwards. So you're also going to have to do it backwards. There's 3 examples here. What's the product of 8 and a number? The product of 8 and a number. Well, when you see a number, if they don't tell you what it is, what should you be plugging in there? X, right? So, or any variable you want, okay? So if I want the product of 8 and a number, what would that be? 8 times a number. So I don't know what that number is, so I'm going to put 8 times x. Good. Do I need the dot? No. If I write it like this, 8x, that means the same thing. What's another way to write a multiplication symbol? I could put an x. Why don't we usually? Because now it looks like another variable, all right? So typically, once you move into algebra, you don't use that anymore. So you're going to either use the dot or no sign or sometimes parentheses, okay? So all of those mean multiplication. I most commonly write it like this because, again, less writing. Okay, number 2, 5 less than a number. 5 less than a number. Good, Reggie. Why is x first? Because what? You could do it the other way around. But how come this one is x minus 5? Okay, it says 5 less than a number. What does less than do? Switches the order. So that means if a number is second in the problem, it's first in your translated expression. So x minus 5. So watch out for those because those less thans are going to be tricky. The sum of a number and 3 minus 6. How's this one different? It has 3 things in it, right? 3 terms, so there's multiple parts. So the first one says the sum of a number and 3. So what does that look like? So it's sum x plus 3. What do I need? Why? I'm putting parentheses here. Why? Okay, it's a separate expression and you have to do it what? Left to right. You have to do that part first, so you want it in parentheses. Good. So x plus 3 minus 6. Good. Okay, so at your boards, I would like you to do these 10. Before you get up, hang on. When you see squared, what is squared? Times itself or with a little exponent of 2. Okay, what's cubed? 3. Little exponent of 3. And what does twice mean? Multiply what? By 2. Not times itself, but times 2. So if it says twice, that means you're multiplying by 2. Okay, do these 10 at your boards. Make sure you number them carefully. Okay, so translating from numerical expressions to algebraic expressions is one of the things we're talking about, and then we're also going to talk about evaluating. So what would it mean to evaluate the following expression for x equals 8, y equals 5, and z equals 4? What does it mean to evaluate an expression? Okay, so I'm going to look over it, and I see that this says x plus y, but I have some information up here. How can I use this information to... Sorry, what were those first 2 words you used? Plug in, exactly. Evaluate means to plug in, okay? So when we evaluate an expression, essentially what we're doing is plugging in. All right, and in this case, what 2 values am I going to plug in? 8 plus 5, and then what would that give me? 13. Okay, so when we evaluate, we're plugging in numbers for variables, and then we're simplifying if we can. And since 8 plus 5 we can simplify, I know that's going to simplify down to 13. All right, what about number 2? What kind of math is this? Division. How could I say that in words? X divided by z. And what are my numbers that I'm going to plug in there? Which gives me 2. All right, every fraction is a division problem. Every single fraction is a division problem. Because remember yesterday when we were simplifying those fractions to put them in order, we did division. If I write this as a division problem with the little house, where does the 8 go? Inside the box, on the inside. So 8 divided by 4, which gives me 2. Dividend divided by divisor equals quotients. All right, so when we evaluate, all we're doing is plugging in. Sometimes they're going to be really simple. Sometimes they're going to be more complicated. There's no sign here, so what am I doing? Multiplying, so m times n. So in this case, if m equals 3, n equals 2, p equals 9, it would be 3 times 2, which is good. What would this one be? And then this one? Good. Okay, so evaluating is as simple as plugging in and simplifying. What makes evaluating more complicated? Why is it not always this easy? Bigger numbers, maybe? Are they always just going to have 2 variables? No? Sometimes there's going to be 3 variables, so sometimes you might have something like this. All right, what would you do here? Okay, so the first thing I'm going to do is what? Plug in. The first thing you want to do is plug in. So what's that going to give me? Okay, so how do you start this one? Start off by doing everything on the top. So what's 9 divided by 3? 3 over 2. And then what would you do here? I would simplify that. So I'm going to do 3 divided by 2. Does anybody remember from yesterday what this is? 1.5. All right, 1.5. Could you leave it at 3 over 2? Yeah? What is 3 over 2? Improper fraction? I'm fine with improper fractions. Okay, so you can leave it like this as long as that fraction is what? Boxed maybe, but what do you have to do to fractions? No, I simplified it to 1.5. I'm saying you don't have to do that, but could you leave it as something if it were like 6 over 9? No, what could you do to 6 over 9? Simplify. What's another word for simplifying fractions? Starts with an R. Reduce. Okay, so if you can reduce it, you have to, but if it's an improper fraction that's fully reduced, you can leave it like that too. Okay? Once we get to chapter 2, you guys will be allowed to use calculators for the rest of the year on everything, just not in chapter 1 because I want to test if you can do them. Okay? So once we get to chapter 2, you guys will have calculators, at which point none of this should be a problem. Okay? All right, so 3 divided by 2 gives you 1.5. So when we're doing this, how did you know that you didn't do 9 divided by 2 first? What tells you what order to do things in? PEMDAS, order of operations. Okay, so we're going to talk about order of operations a little bit later when we get to simplifying more complicated expressions. All right. Back to your boards. Do these 8s. Do these 8s.